Hello students, welcome to Vetri Neet Gateway. Previously we have discussed the topic about the parameters about motion, right? So we are going to discuss today the second part of it. So we are going to see some basic problems and basic questions regarding the parameters of the motion. Okay, see the first problem here. An object has moved through a distance. Okay, can it have zero displacement? If yes, support your answer with an example. So listen here students, whether an object is moving through a certain distance, so from A and to B. So what is distance and displacement? Distance is the actual path travelled by the body. Displacement is the shortest path between initial and final points. So shortest path travelled by the body between 2 points is the displacement. See, on the previous class, I have told you the previous class video will be provided in the description below. Kindly check that. Okay. See, here the distance is what? For example, A is B and separated by 5 meter means distance is equal to 5 meter and the displacement is also 5 meter, right? So the shortest path is the displacement, that is also 5. The actual path is also the same path only, so distance also 5. So in this case distance and displacement are equal, but in this case see here, so now particle start from this point A and revolves around a circle, okay, and comes finish at the same point B and finish at the same point A. So what is the distance here? So distance is the actual path, how much path it is travelled. So it is, if we consider this is the radius of the circle means, so the circumference of the circle gives you the perimeter of the circle gives you the distance travelled by the particle. So the particle travels will be 2 pi r, this is the distance, very very important application. So see the beauty here, what is the displacement here? So displacement here is the particle starts from the point A, right? This is the starting point and ends at the same point. Whether it is displaced, where it starts, it ends at the same place. So displacement is 0. When will be the displacement will be 0? The initial and final points are same points means the displacement will be 0. Okay. So very very important. Although you are having the distance here, but the displacement is 0. So can it have 0 displacement? Yes. Yes, it can have 0 displacement when we have some distance. You may have 0 displacement when you have some distance also. So this is the best example. This is the best example we have provided you. So copy this. Next is, see the second question students. So which of the following is true for displacement? For displacement, it cannot be 0 here. Whether it cannot be 0? It can be 0. No, it's wrong. Displacement can be 0. In the previous question only we have saw displacement can be 0. When will be the displacement will be 0? Write that point. When the initial and final points are same, the displacement becomes 0. Got it? So displacement's magnitude is greater than the distance travelled by the object. Whether it is true. See, who is greater? Displacement is greater. Displacement is never greater. So displacement is the shortest path, right? It is always smaller than the distance only. Okay. See in an example, a particle travels towards east. A particle travels towards east for 4 meter. Let's say we can say 4 meter. So small number we can take 2 meter. Then after travel 2 meters, it head towards north and it travels for 3 meter. Find distance and displacement. Find distance and displacement. So what is the distance? Distance is the actual path, right? Distance is the actual path. So distance is equal to, what is the actual path here? Which is equal to 2 plus 3, 5 meter. What is the displacement here? Displacement is equal to, this is the starting point. Let the starting point be B and the final point, this is the B. A, B. Okay, the starting point is A, let the starting point is A and let the finishing point be, ending point will be B. So what is the shortest distance between A and B? This straight line, right? This is the shortest distance. How we can find the length of this line? By using Pythagoras theorem. So right angle triangle, Pythagoras theorem we can use. What is Pythagoras? Hypotenuse square is equal to opposite square plus adjacent square. So x square is equal to 2 square plus 3 square, which is equal to 4 plus 9, which is equal to 13. So x square is equal to 13. Therefore, x is equal to root of 13 meter. Okay, x is equal to root of 13 meter, which is very, very small, smaller than the distance. Distance is 5. If it is root 16 means, what is the value of root 16? 4. But here there is no 16, 13 only present. Okay, so 13 is very much less than 4 only. It will be come across 3 point something. So definitely displacement is always, so note that, displacement is always lesser than or equal to distance. So what you can able to learn? Distance and displacement can be, may be equal. It is having the chances. Distance and displacement may be equal in certain cases, but there is no chance for displacement is not greater. There is no chance for displacement would not be greater than the distance. It is always, displacement is always lesser than the distance. Got it? Yes. So a farmer moves along the boundary of the square of the field's side 10 meter in 40 seconds. Side, boundary of the square field. Square field means all sides are equal, right? So the side is how much? 10 meter means all sides are 10 meter only. So boundary of the square field of side. A farmer moves along the boundary of the square field of a side in 40 seconds. What will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds? At the end of 2 minutes 20 seconds from its initial position. So to travel 10 meter, it takes how many seconds? 40 seconds. Okay. So how many seconds are in 2 minutes and 20 seconds? 1 minute is equal to 60 seconds. So 2 minute 20 seconds will be equal to how many seconds? 2 minutes is 120 seconds. 120 plus 20, 140 seconds. So total time travel is 140. Total time travel is 140. See, 140 seconds from here. This is the, consider this is the initial point. Consider this is the initial point. Consider from here it travels to here, then moves on. For how many seconds it is traveling? So for crossing 10 meter, how many seconds it takes? 40 seconds. So this is totally how many seconds? So 140 divided by 40 will give you 0 0 cancel, will give you there is no complete revolution. Okay, 12 and 2, so it is in point. Okay, 3.5. Okay, 3.5. So it will round off 3.5 rounds. Totally how many rounds? So for one round it takes 40. For one round it takes 40 means for 2 round again 80, again 120. Okay. See, 3.5 means it will be here. This is the final point. This will be the final point. So what is they are asking? Find the magnitude of the displacement. Magnitude of the displacement. So this is the displacement, right? This is the displacement. Yes. So consider this is yes. We can use Pythagoras theorem. So triangle ABC. X square is equal to 10 square plus 10 square, which is equal to 100 plus 100, which is equal to 200. H square is equal to H is equal to root of 200 can be written as 2 into 100. So H is equal to 10 root 2 10 root 2 meter. This is the displacement. Okay, this is the displacement. Got it? Next, distinguish between speed and velocity. See, we well know that speed and velocity. Speed is nothing but rate of change of distance, right? Rate of change of distance. So it is, the speed is expressed in a definition form. How we can represent in a mathematical form? Speed S is equal to we can take distance as d by time, distance by time. So speed is what quantity? Distance is a scalar, so speed is also a scalar quantity. Okay, here velocity. Velocity is nothing but what? The rate of change of, not distance, it is displacement here. Rate of change of displacement. Next, here velocity is equal to, so we can take displacement as x by t. Velocity is equal to displacement. So velocity is a vector, displacement also a vector. Okay, so it is a what quantity? Vector quantity. So we can say another one difference. It does not provide the direction of the motion. Does not provides direction of motion. Thus provides. So hence it's a vector quantity, right? It definitely gives you the direction. Provides the direction of the motion. Okay, so write this differences. Okay, next, under what conditions is the magnitude of average velocity of the object is equal to its average speed? So magnitude, okay, magnitude of, so we can take V average, which is equal to average speed. So I am going to represent average speed as V average. So what is average velocity then? Average velocity, I am going to represent average velocity as like this. So V, it is curved mode. V, it is curved mode means it is an average velocity. It is straight V means average speed. Okay. So they are asking about the magnitude. When will be the magnitude will be equal? Okay. So they doesn't ask you about the direction. Okay. So magnitude of average velocity equal, when will be equal? So listen, V average will be modulus of V average. Modulus of average speed will be equal to the modulus of average velocity. This is the they asked. So I expressed the given terms in a mathematical form. So what do you mean by modulus? The modulus gives you only the magnitude. The modulus of a vector gives you only the magnitude. See, both magnitude will be going to be equal. Magnitude of speed will be equal to magnitude of velocity. See here, speed is a scalar quantity, velocity is a vector quantity. Both are having same velocity and speed means who is going to differ here? The direction. So both should be equal means the particle should travel in the same straight line. So if both they travel in the same straight line means, when both they travel in the same direction also, not in a straight line, both same in the same direction. If both particles travels in the same direction means their speed and velocity will be always equal. Because velocity talks you about the direction, right? So the direction is not changing. So then the velocity will be automatically equal to whom? The speed. Okay. So under what condition? The condition is write that when the particles travels in the same direction or in a straight line, their average velocity will be equal to their average speed on terms of magnitude. Okay, got it. Next, what does the odometer of an automobile measure? Okay, so if you ride in a bike means you will see some devices like that in the mask. Okay, so one shows the speed and another one has numbers like this. So this is the odometer and this is the speedometer. The speedometer tells you the instantaneous speed. What is the speed of the vehicle at that time? Instantaneous speed means nothing but what is the speed of the vehicle at that time, at that instant. Instantaneous speed. So here the question they asked to, what does the odometer measure? Odometer is nothing but it tells you the how much path traveled by the vehicle. So it tells you the total distance traveled by the odometer, tells you the total distance traveled by the automobile. Here they given automobile only, right? So odometer tells you the total distance traveled by the automobile. Okay. So 7th question, what does the path of an object look like when it is in a uniform motion? So when an object is said to be in uniform motion means the wonderful condition is uniform motion means the particle follows what condition? The particle should be in constant velocity. This is the main condition. If a particle is said to be in uniform motion means it indirectly tells you the particle is in a constant velocity. What is the velocity? The rate of change of displacement is constant. Okay, not in terms of magnitude but also in direction. Okay, a particle travels straightly, which means the particle travels in the same direction throughout its journey by making the same speed. The direction is same, the speed is same, then you can say it is a constant velocity, right? So the path of the object looks like when it travels in the same direction means its path looks like what? A straight line. So constant velocity means same speed plus same direction. When a particle travels in the same direction means then it looks like a straight line. So the path looks like what? A straight line. This will be the answer. Got it? Next. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. T is equal to how much? 5 minutes. So always do the problems in SI units. What is the SI unit of time? So seconds, right? So 5 into 60. So which will be equal to 300 seconds. Okay. Okay. What was the distance of the spaceship from the ground station? They are asking the distance. Okay. D is equal to question mark. Got it. Next, the signal travels at the speed of. So speed they have given. Speed S is equal to what? 3 into 10 to the power 8 meter per second. So this is in SI unit only. No need to convert. Okay. What is speed? Speed is equal to distance by time. So distance is equal to speed into time. What is speed? 3 into 10 power 8 and into time is how much? 300. So totally we can rewrite as 3 into 10 power 8 into I am going to write 300 as 3 into 10 power 2. Yes, I can able to write, right? So the numbers 3 into 3 is 9 into how many? 10 power 8 plus 2, 10 power 10 meter. So distance should be in meter, right? So 9 into 10 power 10 meter. This will be the answer. Okay. Okay, students. Till now we have saw some problems. Don't enter directly into the problem section. First understand the conceptual clarity on the previous video which will be provided in the description below. Okay.